Welcome back to Edupedia World. In the last lecture we saw about the image formation using a convex lens. This lecture will be focused on the image formation using a concave lens. In the case of concave lens, there will be only two cases. One is when the object is at infinity, and second is when the object is anywhere other than infinity. That is, the object is between infinity and the lens. So let us see the cases and let us also understand why there will be only two cases. Now, in the case of the object being at infinity, we will have two cases similar to the convex case. One will be when the parallel rays of light is parallel to the principal axis. Second, when the parallel rays of light is not parallel to the principal axis. So let us begin with case 1. Object at infinity. So the ray diagram will be quite similar to the case of the convex lens. Just we need to remember the properties of concave lens, that it is a diverging lens rather than a converging lens. So let us see how will it behave. This is my convex lens. First step, draw the principal axis. Now, since the rays of light is parallel to the principal axis, it will be something like this. One ray of light, let's draw it here. The second ray of light, let's draw it here. Now we know that in the case of a concave lens, the rays of light will diverge. Okay, so for real, the rays of light will go back like this. But if we extend it behind, then it will meet at the focal point. Similarly, for this ray also, it will meet at the focal point if we extend this ray of light behind. So the image is formed at my focal point. For the concave lens, this is f2. I get a point image which is virtual at the focal point. So what are the properties? One, it is virtual. Second, it is diminished. Okay, and third, what we'll see is that this is actually a erect image that we can find out in the non-parallel case. So let us deal with the non-parallel case. My lens, principal axis. Now for the non-parallel case, one of the rays of light I will pass through the optical center, and the other I will pass through my f1. Okay, so let me draw this through the optical center, and other ray of light should pass through the, it will be somewhere like this, through the focal point, and these rays are parallel to each other, not parallel to the principal axis. So we know that the ray which on extrapolation passes through the focal point actually becomes parallel to the principal axis, right? And this is the ray of light which goes undeviated. So if this ray of light which is going parallel to the principal axis, if I draw it back, then it would cut this ray over here. Okay, and therefore my image let me use a different color. My image will be formed here. Why? Because I'm using a different color. This ray of light on being pulled back, this ray of light on being taken here, it cuts this ray of light over here. So this is my object, and image was somewhere at infinity here, right? So here what we see is that the image is erect. As I said here, we'll find out the image is erect. So the properties are, again, it is virtual, not really meeting. It is virtual, it is diminished, and it is erect, right? And fourth point is that this point will actually be the focal point. This will be my F2. So the object is at F2, at focal point. So for both the cases, the image, sorry, this is my image, this is my object. Pardon my mistake. The image will be at the focal point. So this is overall the first case when the object is at infinity. The second case is object is at any other location. Object between infinity and lens. Okay, so let us draw the ray diagram for this case. My lens, first step as usual, the principal axis, identify the points. Again, this is my F2, this is my 2F2, this is my F1, 2F1. Let me take the image somewhere out here. You can take it anywhere, but for the sake of showing it somewhere, I am showing it here. This is my object. Now let me draw one ray parallel. So after striking the lens, it will diverge away, and if we extrapolate it back, it will meet my F2. So it will diverge away something like this, such that it extrapolated back meets at F2. Second, I will pass it through my optical center, and passing through the optical center means the ray of light will be something like this. So my image will be formed over here, okay, and it will be erect, it will be diminished, and it will be between optical center and F2, right? And also it will be virtual. So let me write the properties. Virtual, erect, and third is diminished. Okay, so these are all the cases in case of a concave lens. In the case of infinity, the image is formed at the focal point. In any other case, it is formed between the optical center and the focal point. The image is always formed to be virtual image. It is always formed to be a erect image, and it is always formed to be a diminished image. Now for the sake of argument, let's say that the object was somewhere else. Let's use a different color and try to see what happens. Let's say that the object was somewhere here. Okay, what would have happened is one ray would have gone like this, and again it should pass through this, so something like this, and another ray would have gone through to go through the optical center, something like this, so the image would have formed over here. Similarly, if the object was somewhere here, you can again draw a ray of light like this and another ray of light like this, draw it behind here, so again the image would have been somewhere there. So you see that in all the cases a similar phenomena will occur. It does not really matter where the object is in case of a concave lens. Okay, so we have seen a varied number of scenarios in case of lens, in case of convex lens, in case of concave lens. We saw how the image is formed, the nature of the image, and this should give you a good insight about image formation in the case of lens. So my hope is that you will do some practicing on your own, and that will give you a lot more insight about the nature of image formation using a lens. So this brings an end to today's lecture. The next lecture I will briefly touch upon what is known as the power of a lens, and we might see a few examples to elaborate that point. I hope you enjoyed this whole past couple of lectures on image formation. See you in the next lecture. Till then, have a great day. Goodbye.